Cultural media are essential tools in microbiology. Essential tools in microbiology used to grow, comma, maintain, and study. I come again. Culture is the essential tools used in microbiology to grow, comma, maintain, and study microorganisms. Study microorganisms. Now, if I may ask, which equipment do we use for that? Which equipment do we use when we're doing cultural media? Especially dish and equipment. Autoclave is one. Incubator is two. Actually, we have autoclave. I believe you have seen it now. The problem with autoclave is you need NEPA lights. Without light, you can't use autoclave. The generator cannot carry it. That generator cannot power the autoclave. It will just damage the generator. So there must be steady light. But freezing, we have been having light in the lab this period. I don't know if you have experienced that. There's a particular pressure and temperature for you. 121. That's the pressure gauge. So 121 in terms of temperature, yes, degrees Celsius. Autoclave, for example, now it has valves like this, valve here, and that one here. So that valve is the cover. This valve, once you put it, you cover it like it's like you're knotting something, cover it back so that it will stand straight. Are you getting it now? Yes. Now when you put it on, you observe that particular temperature you want to make use of. When it's time, you quietly off it. Now after offing it, you remove the valve. Once you remove the valve, vapor will come out. If you don't remove the valve, you can't open. If you try it, it's dirty. Yeah, because the thing will just fling you, throw you away. So for you to be able to open it, now let's say the pressure gauge is already 121, it's somewhere here. It's like a meter. So when you open the valve, this thing will be dropping down. So the temperature will be what? Reducing. So as it's reducing, the vapors are coming out, escaping. When it stops, then you can now open it and bring out the agar you want to prepare. Are you getting it now? So for you to play good culture media, there are certain conditions that your agar must meet for you to say, okay, this agar is good. There are certain conditions. Now, before we go into that, you know there are different types of culture media. Who can tell us one? So we have basic media under the types of culture. We have basic media. When you hear basic, what comes to your mind? Foundation. Now, basic media, right? Basic media provides support. They provide support and nutrients. They provide support and nutrients for the growth of non-fastidious bacteria. For the growth of non-fastidious bacteria. Now, an example of basic media, we have what? Nutrients, agar. If you check most microbiology culture, they always like using what? Nutrients, agar. That nutrient agar is like a general agar. But there are other specialized agar. There are some agar that can only isolate staphylococcus. Only. You can't use any other thing. Only staphylococcus. That is where that selectivity comes in. But generally, you can use nutrients, agar for non-fastidious bacteria. Now let's take an example. Enriched media. Enriched media. Who have idea of enriched media? When you use that word enrich, you know what comes to your mind? Supplement. Like, for example, now, let's take food for a case study. What's everything akamu and custard? Custard and akamu, actually, they are almost the same. The difference is those things they add in custard, flavor, and all those things. Are you getting that? They are trying to enrich it. So if you look at that concept, that's what we mean by enriched media. It's not natural, like there are added things to it, like supplements. So right, enriched media. These are media that are supplemented with extra nutrients. With extra nutrients. Extra nutrients. Like blood, serum, to support the growth of fastidious bacteria. Or you can put fastidious organisms. Fastidious organisms. E.g., we have blood agar. Now there are some tests you want to run in the lab that requires blood culture. Maybe there are some infections that are inside the blood. Infection in blood is called what? You can tell me. Infection in blood. What is call it septicemia. When the blood is infected, it's called septicemia. Some book can write it like this. The spelling and the meaning is still correct. You know that one is full, one is septicemia. Infection in the blood. So maybe the person have infection inside the person's blood. The best way to do is to culture the blood. So you now get blood agar. Have you people prepared blood agar in the lab before? Not at all. It's very simple. Now this is how you prepare blood agar. You get nutrients agar. Are you getting it now? Do the normal procedure. Now the moment the nutrient agar is still inside the conical flask and it's ready, turn the blood inside, mix it together. Yes, you show blood now. So when you mix it together, you turn everything inside the petri, your life solidified. Succeeded in preparing it. Once it solidifies, you put it inside the incubator. So whatever microorganisms that is inside the person's blood will come out. That's how to prepare blood agar. It's simple. It's not something that they call. But you know that most times people use urine or they do HBS. But there are some serious conditions that will require both blood culture and other cultures. There are some that will require you to scrape the person's skin. There are some infections you will see. The person's skin is what you want to culture. You will take something, you scrape it. Then you will do microscopy for it. You put it on a glass side. Then you also prepare culture for it. You now view under microscope if you see anything inside. So there are different types of sampling when it comes to culture. Now, selective media. Selective media contains agents that inhibit the growth of certain microbes. It contains agents that inhibit the growth of certain microbes while promoting the growth of others. While promoting the growth of others. Now, example of selective media is what? McConkey agar. Now, if you look at that statement, selective media means that the agar can stop the growth of some microorganisms and allow the growth of the one that it wants to allow. That's selective media, means that it is selective. Now, this McConkey agar facilitates the growth of majorly gram-negative bacteria. Majorly gram-negative bacteria. Then we also have what we call differential agar. Media, sorry, differential media. differential media, these are certain indicators. These are certain indicators that allows. These are certain indicators that allows differentiation between microorganisms. Differentiation between microorganisms based on metabolic activities. Based on what? Metabolic activities. E.g., we have mannitol agar. Mannitol agar. Or you can call it, there's another name for it. Please, you can write mannitol salt agar. This one is preferable for me. Mannitol salt agar. Then we have one more I want to add to it, which is transport media. Transport media. Now, this type of media, are you there, are designed to preserve microorganisms during transport. They are designed to preserve microorganisms during transport without promoting growth. Without promoting growth. Now, what simply connotes is that you use this particular media, what it does is that it will preserve a particular microorganism. In the course of transporting others, one will remain, nothing will happen to that one. It will just be there. That's the work of transport media. Now we have talked about different culture. And most times in the lab, so far so good, this is what all of you have been using. Now this is for culture media. Now, you and I know that you can do different types of culture. And that's why most times for culture is just one test. The three goes together: culture, microscopy, and sensitivity. The three of them go together. It's very good to the three so that you're able to some things that you cannot see under the microscope. You see them through culture. There are something you see culture, you will not see them culture, you see them under the microscope. Are you getting it now? Then the essence of sensitivity is to provide solution to find out which of these drugs can inhibit the growth of that bacteria. And that's the reason why most people will see them treating without doing tests. You will take drugs for a very long time, it's not working. It is because the drug you are taking, that bacteria is resistant to that drug. So no matter what you take, the bacteria will just be there, they shit, nothing. Nothing will happen. Until you bring something that it does not understand. And funny enough about bacteria, bacteria have their own mechanism of protecting themselves from that drug you want to take. So if you don't know, you are just taking drug, the bacteria can arrange enzymes that will help him dissolve the drug without anything happening. That's the reason why we treat a particular thing for God knows how long. It's not working. Not because you are not doing the right thing, but because you are not taking the right medication. That's what we call bactericidal and bacteriostatic. When a drug is bactericidal, it means that drug will kill the bacteria totally, will destroy the bacteria. But when it is bacteriostatic, it will not destroy the bacteria. It will slow the activity of the bacteria. The bacteria becomes weak. Later, the bacteria will come up again. So if it is the kind of drug you are taking, you feel okay for like some days. Small time again, the sickness starts again because of the bacteria. So our main focus today will talk about staphylococcus. If you have been doing lab, you tell me you see staph, you see staph, you see staph. You need to know about staph. How does staph affect human being? What does it do? There are some chemicals it release. There are some poisons that staph do release. It is very important. Classification of culture media. Classification of culture media. Now, culture media can be classified based on consistency. Based on consistency. Now we have solid media, we have liquid. And we have semi-solid media. So, example of solid now, you now say e.g. agar. Now, what about liquid? Semi-solid. What is agar? Agar is an inert carbohydrate. Agar is an inert carbohydrate extract obtained from a type of seaweed found in countries like Japan and all that. You got it from seaweed. And most times it's available in powdered form. Now, a good brand of agar must have the following conditions. Brand of agar must have the following conditions. One, it must be a gel at a concentration of 1%. Then two, melt at 98 degrees Celsius. That's the reason why you put on your gas, on it and leave it for some time so that it will boil, to melt. Then three, it will set on cooling, and you allow it to cool at 42 degrees Celsius. Then four, it must be easily soluble and maintain clarity that is very clear in solution. That's the reason why when we are leaving it, we allow it to become pure, like clear, before you can make use of it. Then another thing you can use if you don't want to use agar, we have what we call gelatin. Gelatin. But agar has advantage over gelatin. Agar has advantage over gelatin. Now let me ask you a question. How do you prepare chocolate agar? You have idea? If you want to prepare chocolate agar, all you need is just blood plus heat. You get chocolate. I'll also have staphylococcus epidermis. Now, most times when you talk about culture, we are used to hearing this or seeing this. Now the question is, what is the normal flora of staphylococcus? Where is it found normally? Nasal cavity, apart from nasal cavity, where again? The other place is skin, yeah. There you can see it. Skin. Number one. Upper respiratory tract. It's another place. Upper respiratory tract. And intestinal tract. The skin, comma, upper respiratory tract, and intestinal tract. Note, Staph aureus is carried in about in the nose of about 20 to 40% of healthy individuals. 20 to 40% of healthy individuals have staph in their nose. With that catarrh you are blowing. Now characteristics. They are gram-positive cocci. They occur in what? Clusters. They are gram-positive cocci. Pairs or singles. They can also mean pairs or singles. They can ferment carbohydrates without gas. they can ferment carbohydrate without gas. The colonies, let me wait if I say it. The colonies may be gray, are you there? White or golden yellow. Maybe gray, white or golden yellow. Now this aureus is derived from the Latin word. Are you there? Aureus meaning golden. This aureus means golden. Golden. They are allophilic. You know what I mean by that? They are allophilic. You know what allophilic is? Salt loving. God bless you. Salt loving. You love salt. Now let's look at pathogenicity. Things that Staphylococcus aureus can cause. What it can cause. Number one, it can cause conjunctivitis in neonates. Conjunctivitis in neonates. You know what conjunctivitis is now? You have idea? Conjunctivitis, yes, it has to do with the eyes. There's a way if somebody is pregnant, for example now, and the person has staff, it can affect the eye of the unborn child. It's as bad as that. There are some child that are born with one eye small, very small, almost to close. It's infection. They are not born that way. Like there is no natural. It's infection the mother had when she was pregnant. There's even like Neisseria gonorrhea can make a child go blind. So as a woman, if a woman is pregnant, she wants to make sure that she is free from all these infections because it can affect your body. Number two, septicemia. Septicemia, we already said it's infection of the what? The blood. The blood is infected. Number three, pneumonia. Can lead to pneumonia. It can even lead to poison, food poison due to a particular toxin. Food poison due to enterotoxin B. Enterotoxin B. That will cause food poison. Alright, let's look at enzymes and toxins released by Staph aureus or produced by Staph aureus. Enzymes and toxins produced by Staph aureus. Now we'll start with the enzymes. Now under the enzyme, we have what they call hyaluronidase. I will tell you what it does. One by one. We have coagulase. We have what's it called? Staphylokinase. We have beta lactamase. We have deoxyribonuclease. These are enzymes. You know that when somebody has staph, if you go close to that person, the person will get it, have you? It simply means that it can be spread, isn't it? There is something that staphylococcus uses to spread itself. That thing is called hyaluronidase. Are you getting it now? You can write. This is the spreading. This is a spreading factor that aids staph aureus to invade the tissue. This is a spreading factor that aids staph aureus to invade the tissue. Probably from a particular spot where it was, it will now be spreading through the help of this enzyme called hyaluronidase. Hyaluronidase to be spreading up and down. So that's why it's easy for someone to contact from another person because of this. Alright. The next one is, let's take deoxyribonuclease. You know what they do with enzyme? This enzyme helps staphylococcus to destroy DNA. People don't know the power of that thing. You just see it in lab, just see that it's one child's play. No. Do you know staphylococcus can cause miscarriage? You can make somebody can have miscarriage. It's as bad as that. Very stubborn bacteria. Very stubborn. So it makes some enzyme to destroy DNA. Now we have staphylokinase. Staphylokinase. This enzyme causes what we call fibrinolysis. Fibrinolysis. What is fibrinolysis? The breakdown, splitting of fibrin. Or fibrinogen. Sorry, or fibrinogen. Sorry. Another one is coagulase. Who can remember this coagulase? We have done it in the lab before. Yes, to test for the what? For staph. Are you getting now? So this is an enzyme that staph uses to convert fibrinogen to what? Fibrin. So you write staph aureus produces coagulase which clothes fibrinogen in plasma to form fibrin. It clothes fibrinogen in plasma to form what? Fibrin. That fibrin will enhance the clotting of what? The blood. So when somebody has staphylococcus, if you mix it with blood sample, the blood will clot. Only clot. Yes. The enzyme that uses coagulase. Now another one is beta lactamase. This is beta lactamase. Beta lactamase. This is an enzyme that staph always uses to inactivate antibiotics. It uses this enzyme to inactivate antibiotics. That's the reason why if person take drug, the drug will not work. Because the drug the person is taking is a beta lactam drug. And meanwhile, staphylococcus aureus has beta lactamase. So if you take any beta lactam drug, example of beta lactam drug is penicillin. Not that. Penicillin is a beta lactam drug. You are going to do pharmaceutical microbiology 400 level. Where we talk about different types of microbial drugs, antibiotic drugs, and their mechanism of action. That will be second semester 400 level. So it makes some enzyme to invade what? Antibiotics, such as penicillin. Resulting in penicillin resistance. Resulting in what? Penicillin. So anybody that has staphylococcus aureus now, if the person take this drug, it will not work. Because this drug is a beta lactam drug. So the bacteria will use this enzyme to inactivate this antibiotic, it will not work. But if you take this drug for another thing, it will work. But not staphylococcus aureus. So these are things you need to know, have an idea about. Now these are enzymes. Apart from these enzymes, staphylococcus also have poisons that it releases. So let's look at toxins produced by staphylococcus aureus. One, exotoxin. Exotoxin. This is what staph used to destroy red blood cells and platelets. This is to destroy red blood cells and platelets. Now we have enterotoxin. Now this toxin helps staph to withstand the pressure of boiling within 30 minutes. So even if you boil for 30 minutes, staph will survive because of this enterotoxin. And that's how it causes food poison. But inside food, red oil, there's one time we did one research, we saw red oil staph inside red oil. So when he said even if you boil it can survive for at least 30 minutes of boiling. I mean, you know, you will not boil anything for 30 minutes apart from meat. What are you cooking that you're cooking boiling for 30 minutes? You know, so it will survive and stay inside. It will not cause food poison, which will lead to what we call diarrhea. Yes, the person will be stooling anyhow. This is what you want to toilet. Come and give it. You will not take drugs. There's when you eat food, you be purging. Not like the food is beans or anything, no. The bacteria will be stopping you. They will not ask you to take either Therabid or Ofloxacin. Therabid is one of the drug. Or you buy Ofloxacin to not stop that. Going up and down. Diarrhea. So you can cause food poisoning. Diarrhea. Okay. Now there are different types of these enterotoxins. That will be an assignment for you. I have about 4 of them. So find out because of time. Now remember that if somebody has staph, either a male or female, the skin needs to peel off. They have a sore in the skin and it's peeling off. Abi? There's a particular poison that the bacteria releases that make person to be scratching. And as it's scratching, person is peeling off the skin. It's called exfoliating. Exfoliating. This substance causes the skin to peel off. It causes the skin to peel off. In a scalded skin syndrome. In a scalded skin syndrome. Hmm? Scalded. SCALD. Skin syndrome. Now, what are the likely drugs that can fight this bacteria? And the way I am now, not, even without sensitivity, I know drugs that can kill staph. Even if I don't do sensitivity. That's the reason why if you go to hospital, so a lot of be like, you have staph, Abi, they just need to mark you because they already know that this particular drug can fight. Now, we already know that penicillin is a no-go area, Abi. So what are the drugs that can give sensitivity? We have one. We have methicillin, cloxacillin. Methicillin is Methicillin. Methicillin. Cloxacillin. Cloxacillin. Are you there? We have flucloxacillin. There are many drugs, so I'm just naming it. Then we have cephalosporins. This cephalosporin is a group of drugs, not one name. There are drugs under it, cephalosporins. Now, though this one is under chemotherapy. Now, there are still other drugs that are sensitive to staph aureus. That is common. They have erythromycin. Erythromycin is also good against it. Erythromycin is a good one. They have vancomycin. They have there's this common one. ciprofloxacin. So by so doing now, you already know the solution. They have clindamycin. Now, there are still some, there's something I want to make clear. This medicine, eh? There are still some part of staff that can resist this. They call them methicillin resistant staphylococcus aureus. There are some, like inside that staff, there are some that are able to resist what? Methicillin. They call it methicillin resistant staphylococcus aureus. This drug will not work for them. This particular type of staph aureus, the drug will not work for them. So to avoid all these stories that touch, you can use this and avoid this, so that you be sure not to use this. But to be more sure, it is best you do sensitivity test, because what work for Mr. A might not work for Mr. B, and they have both of them have staff. That person might be sensitive to maybe chloramphenicol. It doesn't mean that chloramphenicol can cure for everybody. No, no. Another person can call that chloramphenicol will not work. So that's why it is still best to do sensitivity test. I will not teach you people about how to prepare EGA. You have done that in the lab. These are the extra things you are paying for, so that add to your knowledge about stuff. Because if, for example, now most of the culture you have done so far, they ask you staff. They ask you staff. Now the question, they want to know if you have added knowledge about this stuff. You have other information about stuff. So you now explain. Urine sample was collected, because not just culture, please. You can say you want to discuss urine MCS. For example, I'm not telling you want to discuss staff. I want to discuss urine MCS, meaning urine microscopy, culture, and sensitivity. So now that urine, there are rules, not just any urine. Hope you know. A freshly voided urine, not urine that have stayed for 5 days, you now bring it. You must see something normally, because if you leave urine for some time, bacteria will deposit inside. Were you able to talk this on urinalysis?
No.
Now, let me just give an example. You know, people that used to do analysis, all those biochemists, under analysis, they will call leukocytes. Leukocytes is white blood cells and nitrite. Most girls used to have nitrite in their urine. Nitrite is a sign of infection, but that infection does not have symptoms. It's asymptomatic infection. It's just there, but does not do anything to the person. But when there's leukocyte, the person has infection. That one is sure. But as at that time, you cannot determine which type of infection. That is when urine microscopy, culture, and sensitivity now comes in. You now do culture. So what am I saying in essence? This urine we are talking about now, you collect freshly voided, because they will ask you, what type of urine are you collecting? That's the kind of question you are talking. You'll be like, okay. Where did you collect it? Where and when? You will not tell them that the urine was given in the lab. Don't say the person went home and come the next day. Don't spoil your work. Yes. So you must know this. The urine was freshly voided. Immediately you collect the urine, you prepare agar for culture. Abi? Now, you want to prepare urine for microscopy. What do? You get that urine, put it inside a container, you cover it. You use bucket centrifuge to spin the urine. Hope you are aware. When you spin the urine, something will happen. There will be deposit of sediment at the bottom part of the container. Then you decant the container once. You just decant it and return back. Those sediments will be at the bottom. They will settle at the bottom. It is that sediment you will now put on your glass slide before you put your cover slip. Then view under the microscope. Now the question they will now ask you, what are the likely things you can see under urine in microscope? This is where they will be catching somebody, like they will get you if you don't know what they are saying. There are some things you can see in microscope, like light must be true culture. So you have to be sure what they are saying. Very, very sure. So it is from that place, you now say, okay, you do microscopy. When you do, you saw cast cells, you saw epithelial cells. I don't know if you told about all this. So these are the things we're talking about. Then when you do culture, you saw strains of staphylococcus, but you're not sure. Don't tell them it's aureus. They will ask you, how did you know it's aureus? That is when you not tell them that you did biochemical test. Then you are seeing strains of staph and strep, but you're not sure, you now did biochemical test. What is that biochemical test? Catalase test. Because staph is catalase what? Positive. That's why you now come to conclude that it is what? Staph. But you are not still sure if it is staph aureus or not. You now wait for her to do coagulase test. So by the time you are telling them all these things, they will know that this person understands what he or she is doing. So you have done the first one, catalase test, to separate staph from strep. Now the question is, that staph, do you know the species? No. You will now do coagulase test. It is coagulase that will now prove that it is staph aureus. Are you getting it now? That's the way you are going to present it. Anything culture, you are saying you do culture. Even if it's not staph, maybe you saw, say, E. coli. You will tell them that you did biochemical test for E. coli. By the time you will come tomorrow, all the biochemical tests I will list them for you. And what they are used to test for. The one for staph, the one for strep, the one for E. coli, each of them will tell you. So that anytime you are presenting anything on any of these bacteria, you should be able to tell them that you did biochemical test. Are you getting it? Because that is the only way they will believe that you really did the work. Because on your own, only eye gauge is not enough for you to convince your lecturer that this is staph. They will not ask you, do you know the other species of staph? Actually, it is staph aureus. It is so you must say you did coagulase test. And they'll ask you coagulase test because you must know each of them, what they use, the procedure. You must know them. That's the only way you can defend yourself. There are some coagulase tests that you must know the reagent they use. If you don't know it, problem. Like catalase, you use hydrogen peroxide. Because the work of catalase is to what? You can tell us the work of themselves.
Bring that. So break down hydrogen peroxide to water and oxygen.
Yes. So now staphylococcus have catalase. So you can break down hydrogen peroxide, decompose it into water and what? Oxygen. Are you getting that? But strep does not have that ability. So that one will not differentiate staph from strep. Then you now go further to look at what kind of staph is here, what species or what strain is there. That is when coagulase test will now come in. And when there's staph, what will happen? It will make the blood to form a what? A clot. Using the enzyme coagulase. If you say this thing, they'll give you a no stress. On a short note, give it a because they'll be this person who works. But if you just stop at agriculture, we saw staphylococcus inside the infectious disease. It don't look like who told you that thing you saw is staphylococcus? Actually, you have any evidence to prove it? That's when I'm doing the biochemical test. The inoculation, they will ask you to which kind of method are you using to inoculate? Is it the strip method? Is it the spread method or the populate method? That populate method is majorly used when you're dealing with urine. If you don't, you can just use populate majorly for urine. But when you talk about solid samples like maybe discharge, you can decide to use trick method. You can't put populate because you are using stick swab to collect the sample. Hope you know because that's the technicality. Because see, they can ask you after collecting the sample using stick swab, did you use populate method or spray method? You not say populate or spray method. Now I'm gonna choose populate. I say is it liquid? How do you pour it? You can't pour it now. You see, that's how lecturer twist questions. They want to know if you know what you are saying. You not tell them you pour if you pour the stick swab or what did you pour inside? You say you are lying, you don't know what you're saying. That one is you use trick method. They can ask you what is the thing gram positive bacteria and gram negative bacteria. The bacteria cell wall, the peptidoglycan. One is thick, one is what? No, because that peptidoglycan gives support to the cell wall, like it protects it. So you want to gram positive, therefore gram negative. Then what is inside this peptidoglycan? There are two things that is inside. You have